Time travel into the future isn't fiction, it's physics. From Einstein's equations to black holes and particle colliders, we'll uncover how it's all possible. Stay tuned with AstroBits, your gateway to the universe. And if you love space, science, and mind-blowing facts, don't forget to subscribe. According to Albert Einstein's theory of relativity, time isn't fixed. It's flexible. It bends, it stretches. When you move faster, time slows down for you relative to those at rest. This is called time dilation. Astronauts on the International Space Station experience it every day. They age just a bit slower than we do on Earth. It's not science fiction, it's measured and real. If you could travel at 90% the speed of light, time would slow dramatically for you. What feels like days to you might be years to people on Earth. Push closer to light speed, and time nearly stops. This isn't just theory. In 1971, scientists flew atomic clocks on commercial jets. When they returned, the clocks had ticked slower than identical ones on the ground, exactly as Einstein predicted. These weren't ordinary clocks. They were atomic clocks, accurate to billionths of a second, essential for measuring such tiny time shifts. But here's the incredible part. Atomic clocks work even in space. They're sealed in vacuum chambers and aren't affected by air pressure. Satellites, like those in the GPS system, carry atomic clocks. They experience both speed and gravity-based time dilation and must be corrected constantly. In fact, your GPS only works because we understand and correct for time dilation. So yes, time travel into the future is already happening, just very slightly. And it's not science fiction, it's science fact. Time isn't just affected by speed, gravity warps it too. The stronger the gravity, the slower time flows. Stand near something incredibly massive, like a black hole, and time would crawl. Near its event horizon, the boundary beyond which nothing can escape, time would nearly stop, at least from an outside observer's point of view. Imagine hovering just above that edge. From your perspective, time feels normal, but to someone watching from afar, you're frozen in place, never quite falling in. Einstein's equations predicted this strange behavior, and in 2019, the Event Horizon Telescope captured a stunning image of a black hole, not the black hole itself, but the light warped around it by gravity. That glowing ring? It's light caught in a gravitational trap, circling the event horizon. A real glimpse of time twisted by space. Time travel through gravity? It's already been proven and photographed. At CERN in Switzerland, scientists use the Large Hadron Collider, the world's most powerful particle accelerator, to accelerate protons to an astonishing 99.999% of the speed of light. Inside a massive underground ring spanning 27 kilometers, beams of particles travel in opposite directions at nearly light speed, guided by superconducting magnets cooled to temperatures colder than outer space. At these speeds, time begins to behave differently. For the protons, and for certain fast-moving particles like muons, time slows down dramatically. Muons, which normally decay in microseconds, survive far longer when moving at relativistic speeds. They're literally experiencing less time, aging slower than they would at rest. This is not science fiction. This is time dilation, predicted by Einstein and confirmed in the real world. At CERN, we're not just smashing particles, we're watching time bend. Can we go backward in time? That question fascinates scientists and science fiction fans alike. But according to Einstein's theory of relativity and nearly every test we've ever run, the answer is probably not. Why? Because going back in time would break something fundamental: causality, the principle that a cause must happen before its effect. If you traveled back in time and changed something, like preventing your own birth, you create a paradox. But here's where it gets weird. Some solutions to Einstein's equations do allow for backward time travel, theoretically. Things like wormholes, which are shortcuts through space-time, might connect two different points in time. Then there's the idea of cosmic strings, hypothetical defects in space-time that could loop time backward if two passed each other at near light speed. Even physicist Kip Thorne, who advised on Interstellar, once showed that traversable wormholes could, under very specific and exotic conditions, allow backward time travel. But here's the catch. We have zero experimental evidence that these things actually exist, let alone that we could ever build or control them. So for now, time travel to the past remains a tantalizing idea, one that lives in equations, imagination, and maybe, just maybe, the distant future. Future time travel isn't science fiction, it's science fact. We've already observed it in orbiting satellites, high-speed jets, and even inside the world's most advanced particle colliders. Here's the bottom line. The faster you move, or the deeper you are in a gravity well, the slower your time flows compared to others. This means, in theory, if you boarded a spaceship traveling near the speed of light and returned after what felt like just a few years, decades, or even centuries could have passed on Earth. You'd step into the future, a world transformed, people you knew long gone, technologies evolved, maybe even civilizations changed. And yet, for you, it was just a blink. This isn't just a concept, it's already embedded in our GPS satellites. Without correcting for time dilation, GPS wouldn't even work accurately. So we're not guessing anymore, we're living it, just on tiny scales. The real question is, can we scale it up? Can we build the engines, solve the energy challenges, and survive the journey? Time travel into the future is real, but mastering it, that's the next frontier. And maybe it's how we'll explore the stars. Time travel into the future is already happening, just on small scales. But as our technology improves, who knows? The journey to understanding time is just beginning. Subscribe to AstroBits YT for more science that bends your mind and takes you beyond the stars. Because in space and time, we're just getting started.